Hi guys, this is Miss Brown speaking. So this is going to be our second day solving and graphing inequalities. And I told you yesterday that solving inequalities is almost exactly like solving equations, but there is a slight and pretty important difference. So I want to help you understand what's making the difference here. So remember that when we are working with inequalities, we want to do the following. We want to maintain a true statement. Let me get a smaller tip. We want to maintain a true statement. And also, when we are solving inequalities as well as equations, remember what you do to one side of an inequality, you must do to the other. So I want us to consider these two statements about maintaining truth and what you do to one side, you must do to the other. Well, what if I had the following inequalities? And I'm just going to write one inequality because I think we can all agree that, let's say, we can all agree that -2 is less than 3. Notice that is a true statement. Okay, so I'm just going to write that same statement 4 times. And notice this is a true statement. -2 is less than 3. And remember, when we do whatever we do, we need to maintain that true, or we need to maintain truth. So watch this. If I wanted to, let's say, add 2 to this side, and I can do that so long as what I do to one side, I do to the other. If I add 2 to both sides, well, -2 plus 2 is 0. And if I bring down the less than symbol, and then 3 plus 2 is 5, 0 is less than 5. That is a true statement. Well, what if I wanted to, let's say, subtract 2 from both sides? So I hope that we know that -2 minus 2, remember we have to add the opposite. That's -4. So that would be -4 is less than, and 3 minus 2 is 1. Well, -4 is less than 1. That is a true statement. Notice how we're maintaining truth. Well, we've tried addition and subtraction. Let's try the operations of multiplication and division. Let me try multiplying this side by a -1. And then multiplying the other side by -1, because what I do to one side, I must do to the other. -2 times -1 is a +2. I'm going to bring down my inequality symbol, and 3 times -1 is a -3. So I want you to look at our statement. Now we have 2 is less than -3. Huh? That is absolutely false. Okay, so notice The only way we're going to be able to make that statement true is to reverse that inequality symbol, because 2 is greater than negative 3. Now we have the truth of the matter. All right, well, let's try one more. Let me go and try to divide both sides by, and to make it easier for all of us, I'm going to divide by negative 1. Okay, so I want us to think about this. A negative divided by a negative is a positive. So negative 2 divided by negative 1 would give us positive 2. And I'm just going to copy down that symbol. And then a positive divided by negative is a negative. 3 divided by negative 1 is negative 3. And all of a sudden, I have the statement 2 is less than negative 3. Huh? That's absolutely false. And the only way we can make that true is by reversing that inequality symbol. Okay? So, what I need you to know is we have an issue when we are multiplying and when we are dividing negatives. Notice I said multiply and divide. I did not say add or subtract. And here's the issue. When we are multiplying or dividing both sides of an inequality by a negative number, you must reverse that inequality symbol. Okay? So please absorb that statement and notice what it says and notice what it does not say. Because a lot of times when kids read this, all of a sudden they just start flipping the inequality symbol. And I ask, why did you do that? I don't know. Guys, it says when you multiply or divide, it does not say add or subtract. And you have to multiply and divide the both sides, not just one side, both sides, okay, by a negative number. It says nothing about a positive number, okay? You must reverse the inequality symbol. And if you do not reverse that inequality symbol, what you are essentially doing is producing a false statement. All right, and that's why your answer would be incorrect. Let's look at problem number 2 together. So again, we're going to solve this. And our goal is to isolate the variable. This time the variable happens to be on the right. So we need to look on the right and find the constant. The constant is the number without a variable, which is that positive 16. The opposite of positive 16 is a negative 16. But what we do on one side, we do to the other. Now, here's where kids will start trying to flip the symbol. But what did we just do? We subtracted 16 from both sides. All right. Does this say anything about subtracting 16? It doesn't say subtracting. It says multiplying or dividing. So at this moment, we have absolutely no reason to flip that inequality symbol. If you cannot tell me why you are reversing the symbol, then you're probably doing something wrong if you just flip it for no reason. Anyway, 8 minus 16 is negative 8. Okay, I'm going to bring down the negative 2x, and then 16 minus 16 is 0. So our new inequality is negative 8 is less than negative 2x. Again, we're trying to get our variable by itself. Our variable is over here. And right now, our variable is being multiplied by a negative 2. Well, to undo multiplication, we need to divide by negative 2. But what we do to one side of an inequality, we have to do to the other. Now, here's where I need us to pay a lot of attention to what we're doing. Notice that right here, I just divided both sides, not one side, both sides of an inequality. I divided both sides by a negative number. What must happen right now? I must reverse my inequality symbol. So now my inequality symbol will be pointing in the opposite direction. If you don't reverse that inequality symbol, your answer is going to be incorrect. Okay, so negative 8 divided by negative 2, a negative divided by a negative is a positive. 8 divided by 2 is 4. And then negative 2 divided by negative 2 is a positive 1x. So I have 4 is greater than x, which is the same thing as x is less than 4. Okay, those two statements are the same. Okay, now we have to remember, do we need an open circle or a closed circle? Well, since it's just a less than symbol, we need a open circle at 4. And this graph is going up by increments of 4, 0, 4, 8, 12. So I need an open circle on 4. And then I need to highlight or put an arrow on all numbers that are less than 4, which would be all of the numbers to the left. And that's my graph. Okay, let's look at the next one. So our next problem is 4 minus n divided by 2 is greater than 1. So I'm going to go ahead and draw my line. Remember that inequality symbol divides this into two sections. And I'm going to isolate the variable or get the variable by itself. The variable is on the left. So I need to look for my constant. My constant is that positive 4. So the opposite of a positive 4 is a negative 4. But what we do to one side of an inequality, we have to do to the other. So 4 minus 4 is 0. So we're left with a negative n over 2 is greater than negative 3. Okay, notice I did not reverse the inequality symbol because I subtracted 4 on both sides. All right, that does not meet the qualifications. So I'm trying to isolate the variable, and the variable is over here, still on the left. And I need us to talk about this negative n over 2. Okay, I hope that we realize that negative n over 2 is the same thing. It's a negative number, right? So I could write that in different ways. I could write it as negative n over 2 like that, because a negative divided by a positive is a negative. I could write it like this as well. N divided by negative 2. Because again, a positive divided by a negative is still a negative. So to make things a little bit easier for me, what I'm going to do is I'm going to consider this as negative 2. All right. So anyway, right now I have to isolate the variable. The variable n is being divided by a negative 2. So I have to think, okay, how can I undo division by negative 2? I can undo division by negative 2 by multiplying by negative 2. And it's okay if I do that, so long as what I do to one side, I do to the other. But I want you to look and pay careful attention at what just happened here. Right here. I just multiply both sides of an inequality by a negative number. Remember, our rule says when you multiply or divide both sides of an inequality by a negative number, you must reverse that inequality symbol. I have to reverse that inequality symbol right now, or else I'm going to get false statements and incorrect answers. Anyway, what's going to happen is this negative 2 is going to divide into that negative 2, giving us a positive 1n. And then on the right-hand side, negative 3 times negative 2 gives me a positive 6. So my answer is n is less than 6. So what I'm going to have to do is, first of all, think, do I need an open circle or a closed circle? Well, since it's just a less than and there's no equal to symbol, I'm going to need an open circle at 6. Oopsies. I think I missed the 6 there. Open circle at 6. And then I am going to need to draw an arrow or highlight all the numbers on that number line that are less than 6. And all these numbers on the left are less than 6. So that would be my graph. Open circle at 6, and arrow going to the left. Okay, let's look at our last example for the day. So our last example says 7 is less than or equal to negative 2 minus x divided by 4. So remember that this stuff up top is considered to be in grouping symbols. And right now, all that stuff up top is being divided by 4. We really need to get rid of that division to make our life simpler. So what we're going to do is we're going to multiply this side by 4. And that's okay so long as what we do to one side, we do to the other. Now, here's where kids will start flipping the symbol. Said, Miss Brown, I just multiplied both sides by 4. Yes, but it's not negative. Okay, so it doesn't meet the qualification. Make sure you know when you multiply or divide both sides of an inequality by a negative number. That's why I really need you to really consider what you're doing. You must reverse the inequality symbol. So, yeah, we just multiplied both sides of the inequality, but that's a positive number. So that does not meet that qualification. So we do not need to reverse the symbol. So that symbol should stay as is. Anyway, 4 times 7 is 28. And then what's going to happen over here is this 4 in the numerator and denominator are going to divide out, leaving us with a bunch of 1s times the stuff in parentheses. And when we multiply all that out, all we're going to have left is negative 2 minus x. So we have 28 is less than or equal to negative 2 minus x. Okay, so let's focus. When we are solving inequalities, we want to get the variable by itself. Well, the variable is over here, and we have to ask ourselves, well, why is the variable not by itself? Well, do you notice that there is a negative 2 over there with the variable? Well, how can we get rid of that? What's the opposite of a negative 2? The opposite of a negative 2 is a positive 2. We can also think of that as adding to. But what we do to one side, we have to do to the other. So 28 plus 2 is 30, is less than or equal to. And then negative 2 plus 2 is 0. Now be very careful. Notice what's left over here. What's left is a negative x. So we have to bring down that negative x. Okay, well, here's the issue. You might be like, okay, I've got the variable by itself. Well, there's a slight problem. I need to know what x is equal to, not negative x. So we got to get rid of that negative. You might be like, well, how? Well, remember our nice little rule that tells us a negative times a negative equals a positive? We're going to use that rule. And we are going to multiply this side by negative 1. Okay? And we can do that so long as what we do on one side of an inequality, we do to the other. But hold on, wait a minute. Let's think about this thing. What has just happened here? We have just multiplied both sides of an inequality by a negative number. We just multiplied both sides by a negative number. What must we do right now, or else we're going to produce false statements? We have to reverse the inequality symbol. At least that's what my cat says anyway. So we're going to reverse the inequality symbol. So negative 1 times 30 is negative 30. And negative x times negative 1 is positive x, because a negative times a negative is a positive. So our answer is negative 30 is greater than or equal to x. That you can rewrite that if you want the x first, just flip that around. It means the same thing as x is less than or equal to negative 30. So we have to graph the inequality. Remember that, excuse me, we have the less than or equal to. When we have that equal to symbol, that is when we need a closed circle. So we need a closed circle at negative 30, which would be right here. And then we need an arrow that highlights everything to the left, which would be all of these numbers here. And that's our graph. All right, thanks. Bye-bye.